Hi everyone, welcome to today's lab. This is the video tutorial for Lab 5. For this lab, you need to download an app first, which is a GeoMap app. So you need to go to this website, geomapapp.org. Here you can see the download links. You need to click on Windows. After clicking it, you need to just agree it to start to download, and I already downloaded the app. Sometimes it requires Java, so when you are going to uh, open it, it will ask for Java. If it is not installed in your computer, you can download it automatically. So here it down the Java, it will take you to this link, and you need to agree and start free download. So I didn't have Java, so I also downloaded Java. Then I at first installed the Java setup, this one. So and after the Java setup, this app just works fine. Okay, so let's go to the app. So here again you need to just agree. So here is the interface. Okay, so for that, now the first thing you need to do here is the button for the distance or profile tool. You need to click this one. So it's processing and it will open two more windows. Okay, if this app is in full screen, you couldn't see these two windows. So but if you will click the distance or profiling tool, that button, it will open these two, layer manager and loaded grids. So for the loaded grids, here is the from the drop down menu, you need to select the topography. Okay, so we need to know about the topography first. Okay, so for the topography, we need to select the topography Smith and Sandwell version 9.1. That one we are going to use. So this map is showing you the topography. So for today's lab, we'll going to focus on South America mainly. In the lecture, I think you have already know about the plates, the tectonic plates. So we'll mainly focus on the South America. Okay, mainly the northern and middle part of South America. So let's just zoom into that part. Okay, so I'm just zooming into the northern and middle part of South America. So after zooming in, you need to again select the profile distance or profiling tool, this one. Now you can just draw a line from west to east or east to west, whatever. So I'm just profiling this section. Okay, so the data will come only for this section, from east to west. Okay, from west to east, sorry. So after left clicking it and then release my click, drawing the line, I'll get a profile for this section. Okay, so from the profile you can see in the left, the y-axis, it represents elevation. So I'm talking about the this graph. Okay, this is the topography Smith and Sandwell version 9.1. So the y-axis represents the elevation and the x-axis, it shows the distance. Okay, so just realize it, we are going from west towards east. Okay, so here you can see the elevation is like that. So elevation is based on the sea level. Okay, so 0 is the sea level. Okay, um, you can see the depth, the surface from the 0 to here. So that's the depth of the ocean in the western part. So here the land is here. Okay, topography. Then we can see a sudden decline here. Okay, that's that's the plate boundary. Okay, so that's the intersection of two plate boundaries. And again you can see here the um, so here is actually, so when you are holding your mouse point there, it will show a small circle on the line. If you can see in the left side, you know, on the white line, I just draw, so you can see the small circle. So here is that, so that's the starting of the continent. Okay, then again the Andes is there, so you can see the higher elevation, and for the rest of the continent it's pretty much near sea level. Okay, pretty much level. Okay, after the Andes mountain, and again at the end of the continent again you can see the elevation decline, so that's the sea level, so zero is the sea level. Okay, so in the western side you can things to remember, things to observe: the sudden decline here just at the beginning of the continent, where the Nazca plate met with the South American plate. So there's a plate boundary here. um, I think the TA already discussed about what kind of plate boundary is here. Okay, so uh, remember that. So that's the profiling. Okay, for the next part we and in this way you can profile anywhere in the world. Okay, if you are interested in some other continents, you can do the profiling for other parts. Okay, so next thing we're going to focus on the earthquakes. Okay, so earthquake, we already know that earthquake is a result of plate boundary movement. uh, for seeing the earthquake data, you need to go to the data layers, geophysics, earthquake, earthquake locations, global USGS ANSS catalog, then the over magnitude 6 or greater, that data you need to select. So you can see from where I am selecting. So this is the data from 1960 till this year 2020. Okay, so when I select this, it will start processing and it will show the point location of the earthquakes, and you can see that most of the earthquakes are on the plate boundary. Okay, and I think you already know earthquake is a result of transform boundary movement or convergent boundary movement. Okay, so here is the earthquake data. Let me just pan some more. Let me focus on the middle. Okay, so I'm just focusing on the middle. So this data, this table shows only the points that are in this area. Okay, so if I zoom out it will show more data, but now it's showing only these points, the data for these points. That's all we need to know for now. Okay, so for analyzing this data, what I'll do, I'll copy the data. Okay, uh, I'll select all. So I'll just control all. I'll select all the data. So I just click on the table. With the with control all, I selected all the data values from this table. Then I'll do the analysis, just the simple scatter plot in Microsoft Excel to see how it looks. So I'll open Excel, blank workbook. Okay, need this layer. Okay, here I'll just control V. Okay, I think I need to copy it again. Control A, select all. Control C, I just copy it, and Control V. Okay, here are all the earthquake data. So we're mainly interested about how the earthquake depths. Okay, so depth means where the earthquake is occurring, at what depth, how it changed from with the longitude. Okay, longitude means if you go from east to west or west to east, how it changes. So we'll just select this longitude column, and I'm pressing control and then I'm selecting the depth column. Okay, so I'm selecting only longitude and depth, those two columns, and then I'll insert a scatter plot. Okay, so here is the scatter plot. Okay, so by the way, this is the title of the graph, it's not the title of the axis. So the x-axis, it's not depth, so let me just edit it. It's longitude, depth plot. Okay, uh, for better understanding, because the depth increasing but it's for earthquake, we need to compare it with the sea level. So 0 is the sea level, let's just flip it. Okay, so I'm just right clicking on the axis, on the y-axis, format axis. I'm just selecting values in reverse order. So now we can see in reverse order, and let's just add axis title so it will be easier to understand. This is longitude. The unit is in degree, and this is depth. So depth of the earthquake, and this is in meter. Okay, so now you can see this is longitude. So if you, from west to east, you can see minus 90, minus 80, minus 70, minus 60. So that's the longitude. We are going from west to towards east. 0 is the prime meridian. Okay, so you can see in the boundary, in the plate boundary, if you look at this one, so most of the earthquake occurs in the plate boundary. Okay, in the convergent plate boundary. In oceanic plate, which is Nazca plate, oceanic plate and continental plate, the convergence boundary. So you can see the depth increasing. Okay, why is that? If you can remember that profile graph, you can see a sudden decrease. So there is a trench there, it created because of the boundary movement, and the depth of the earthquake increased when you go from west to east. It's going down, and then after when the continent started, after the Andes, so there is no earthquake. Okay, so the depths are in meters. So you can see the highest depth is about 650 meters, and most of the earthquake occurs which are more the magnitude is over 6 or over 6. It's about in this range from 0 to 300 meters. Okay, most of the earthquake occurs here, and a few of them occurs after that. Okay, so that's how we can see that the earthquake occurs in the plate boundaries mainly because of the movement and how it increased, and after the boundary movement, how you can see there are no earthquakes. So here is an evidence that there is a plate boundary there, and it's the oceanic to continental convergent boundary. Okay, okay, so probably we'll ask some question in the quiz regarding this video and the presentation. All the best for the quiz. Thank you.